Okay, the only difference between example 3 and the other 4 examples right above it is we've got to think of some multiplication. It kind of ties in with the first example. But our degree, it looks like it's x to the 1 time multiplying x to the third. That'll give us a degree 4. And it looks like our leading coefficient is negative. It's a negative 18, but we only care that it's negative in order to state the end behavior. So as x goes to negative infinity, y will go to, so it's an even degree, and it's negative. So both y's will point the same direction, and that will be negative infinity. And we're done. I want to discuss problems 7 through 10. I really could not come up with an easy way of doing examples like these. So what I wanted to do was just take a look at 7. And I think that once you get through the notes, you'll be able to work on these. Now, of course, you could just graph all of these. That takes a while to type in. On this one, since, first of all, I'm looking at the degree and leading coefficient. Well, it's odd degree, leading coefficient is positive, so my end behaviors agree on all of them with the graph. What I did, though, was I factored them to find the zeros. Because it looks like we've got like a 0 at 1, and then it looks like another one in between, and then maybe another 0 at 0. So I'm just going to do a quick factor. And I'm going to erase my drawing so I can see the graph better. So when I factor, I get x equals 0 and x equals positive 1. That actually looks pretty close. Let's do a little bit more factoring. So this will lead to x equals 0 and x equals positive and negative 2, because I can factor that x squared minus 4 into x plus 2 times x minus 2. All right, that is definitely not it. 1/3 x to the third plus 1/2. So I can still factor this x squared, and I get 1/3 x plus 1. That'll give me a 0 at x equals 0. And it'll also give me an x at, subtract 1, multiply by 3 at x equals negative 3. Well, I don't see a 0 there either. And let's look at x to the third minus x. X squared, and then x. Take an x squared out. That's where I'm stuck. Sorry. I'm going to take an x out, and I have x squared minus 1. Well, that will lead to zeros of x equals 0, and also x equals plus or minus 1. I don't see a 0 at negative 1, so it's got to be the first one. Again, you can also pull them up on the graphing calculator and take a look. You can either match it, you can cancel out some with end behavior, you can cancel out some with zeros. This one I had to do all 4 to figure it out. Okay, back to example 4. And as usual, if you have questions, just ask on those 4 problems. Find the interval where the function is positive and negative in interval notation. All right, well, let's factor it. And I'm going to throw in a 0 because the zeros are where it goes from positive to negative. And I get x equals 0 and negative 5 and positive 5, because x squared minus 25 can be factored to x plus 5, x minus 5. Now I'm going to show you how I'm going to figure out how what intervals it's positive and negative. So f of x, x, and I'm going to put my zeros in order. So negative 5, 0, and positive 5. And I'm going to test numbers around those numbers. So the first number I'm going to look at is x equals -6. Okay? Now, I like plugging in the -6 to the factored form. In fact, it would be helpful if I did it. I fully factored this darn thing. I don't know why I was skipping that step. X minus 5, x plus 5. Because it's easier to plug in the numbers and just figure out the sign. So if I plug in a -6, I get a negative when I plug it in for the x in front. When I plug it in for the middle, I also get a negative. And when I plug it in for the last binomial, I'll get a negative. So I get 3 negatives multiplied. That's going to give me a negative for my function. See, I don't really care about the sign, the numbers. I'm just looking for what the signs are. And this is looking a little squished. Try that again. Okay, I'm just going to use a negative sign. All right, so a number in between -5 and 0 that's easy to calculate with. Let's just use -1. Again, you're going to just think about the substitution. Plugging in for the first x, I get a negative. Plugging in for the second x, I get another negative. But plugging in for the third x, I'll get a positive. So I get 2 negatives and a positive. That will definitely give me a positive. 2 negatives and a positive multiplying. In between 0 and 5, I'm going to go ahead and use 1. And while I'm at it, I'll try 6. And 1, I get a positive, a negative, and a positive. That will definitely give me a negative. So 2 positives and a negative will reduce to a negative. And if I throw in a 6, I get a positive, I get a positive, and I get a positive. So that will be positive. So in interval notation, positive is going to be between 5 and 0 and greater than 5. Sorry, between -5 and 0 and positive 5 and in positive infinity. And negative, not give myself enough room. Negative is going to be less than -5. And it looks like in between 0 and 5. Okay, good time to stop this video.